session of Guardians of the Cloud. So for those of you who joined us last time, you would know that this is a three-part series where we're covering everything about cloud security. So we're starting from last week. What did we cover last week? Who came last week? Sahar. What did we cover last week?
And do some collecting of logs that we do not have to overwhelm it with other operational logs and analyze, and it can report potential issues related to security.
Yeah, exactly. So the first step is to actually be aware of like what is coming into your cloud environment, or even like on-prem, because you said Sentinel can be connected to on-prem environments and even other cloud providers. So after we're aware of what's within the environment, now we're going to take a look at how can you hunt for threats that are in your cloud environment, and how can you detect them, and what weapons and tools do you have in your arsenal to do so. And we have Peter here. So for those of you who don't know Peter, Peter is a solution architect focusing on cybersecurity and AI security, and he has nearly 2 decades, more than 2 decades of experience working in a lot of big projects regionally, and so on. Okay, and just because I see a lot of new faces in the audience, so for those of you who's your first time to the community, welcome. My name is Fatma, and I have here Fateh, Sarmad, and Hamza. We're all part of the Agile Qatar community organizers. This is, again, for those, I know we're in the Microsoft office and we're Microsoft employees, but this is not a Microsoft official event. Here we're just community members sharing our own opinions and thoughts about how to do things in the cloud. We'd love to see new faces. Connect with us after. We have pizza later. Yeah, Peter, on to you. Let's see, what are we going to hunt for this time?
Rabbits. Alrighty, so it's a little bit Looney Tunes themed slides, not like the Avengers or whatever what we did last time. Primarily, I'm a big fan of Looney Tunes, and Elmer Fudd is my favorite hunter, so no better hunter to hunt for threats. Alrighty, so today we're going to talk about some basics around KQL. It's a query language similar to SQL. We'll talk about some operators, some performance tips. We'll talk about detection rules, Jupyter notebooks, summary rules, a lot of fun stuff as I promised last time, and some of it will be technical. So just out of curiosity, how many of you know SQL language, syntax, format? Excellent. How many of you know Python?
Favorite language.
Awesome. Great. So we'll talk about many different things. And hopefully it's going to be more entertaining than last time, and it will be a little bit with a demo as well. Alrighty. So what is, first of all, a threat hunt in an environment? Okay, without reading, but it's basically a process where you as a security professional are looking for something in your environment that your detections miss, right? So it's not something like, oh, I will see an alert, that's threat hunting. No. Oh, I'm hunting for indicators I have this IP. That's not a hunt. You're just searching something that's known or somebody has provided information about, right? So technically, threat hunting is focusing on detecting something that is missed by your detection strategy. So you're hunting for basically a ghost in your environment, or you're testing a hypothesis to see if you have somebody in your network or someone, right? So a little bit from Looney Tunes perspective, right? So detection rules, they will fire once that criteria matches for a detection rule. That's not threat hunting, that's purely detection. Hunting is something when detections don't fire, right? So again, your detections do miss a lot of things. You cannot account for every single item. And there are two things that happen when you do a threat hunt, right? First one, I mean, in general, threat hunts are always proactive and they're not reactive. So what's the difference between proactive and reactive? Can somebody tell me? In terms of incident response already.
Taking the security measures before the incident happens.
Sorry.
Proactive is taking the security measures before the incident happens, and reactive is after the incident happens.
Correct. So threat hunts are always proactive, hypothesis led. So what does this mean when we start a threat hunt? Anyone?
When like the technology fails to find the threats.
No, I'm asking about a hypothesis, what it is, right?
We start with an opinion or a curiosity-based question. How
Correct.
something is missing. Maybe something is.
Somebody might be in my network by abusing this, for example, right? And this is something what our detections miss. And you start basically hunting for that particular hypothesis, right? Hopefully that makes sense. And ultimately, it's data-driven, which means that if we have the data, we will be able to find it, right? But if we don't have the data, we go back to the previous week's discussion. We need to have the right data in order to detect and hunt as well. Hopefully that makes sense. All right. So KQL as a language, it has a lot of operators, right? So similar to SQL language, you have where you filter, right? So you can see it here, where time generated ago 1 hour, which means that we are looking for events in a table called sign-in logs for the last 1 hour, right? Okay. Then we have project. Unfortunately, I don't have project in this statement here, but project is basically displaying a particular table. Well, sorry, a particular column from the table itself, right? So this particular table, sign-in logs, has user principal name, and it has an IP address as a column inside the table itself, right? Then extend. Extend is basically where you create a new column based on specific parameters, whether that is a string or a computation or renaming a particular table or concatenating particular columns from a table itself, right? Summarizing, basically mathematical functions where you can aggregate, count, deduct, and many other things, find unique values in your table. Join union, again, self-explanatory. You can join or union multiple tables based on different parameters. Sort by, take top, basically ordering and taking top 10 events, or basically it's used to restrict the number of columns you will get from a particular result from your query. Any questions? Okay.
Does the order matter?
Order particularly matters. And it's part of the next actual section that I'm talking about, but every stage, so consider this a stage of your query. So by default, if you run a query with your default settings, actually it will fetch the last 24 hours of data. So if you put time generated here after where result type is anything else than 0, the first thing is going to happen, this is going to fetch all the data for the first 24 hours of the default parameter. And then it's going to apply the time generated filter. That's join and union. Alrighty. So when we union two tables, right? That means we have two tables that have similar layout, which means that all the columns will be clustered together. So both tables will be joined as one with a union, right? So it's just basically union two tables. But when you use a join, this is basically we are joining two tables based on a specific parameter. Like for example, in SQL, we would join on a primary key, right? Or on a specific table there. So for example, you can join sign-in logs with another table, and you will say, I want to search based on an IP address, assuming that the IP address is the unique variable you want to join. I do talk about it in more details in the next slide, but
one simple analogy I like to think about it is union is when you add rows and join is when you add columns. So you need like some sort of key to base it on. Yeah.
So again, like from my perspective, union, if you just join two tables together, no nothing, right? So it's just like add one to the other. But this one is when you want basically results from another table to be displayed in the same column, in the same row, sorry, for you, in the same rows. Yeah. That's the difference, primarily. All right.
Use this like a database language for SIM?
For this particular SIM, correct. Alrighty, so we have a couple of parameters when we do filtering. So when we do that particular statement where, and you have the column name, then you have some sort of string matching capability, right? So if you use equal, it's going to be case sensitive, and it's the most performant way to search, right? But when we want to search for a specific word or a specific pattern, we have different, let's say, things to match with, right? So you have has, contains, and you can use regular expressions as an example, right? But there's also starts with, ends with, so on and so forth. So from these pattern matching, let's say, functions or however you want to call them, the fastest is has. Second fastest is contains or starts with, ends with. Slowest are regular expressions.
That's due to the complexity of the process, right?
It's the way how they process the data itself, right? So has basically works on the word itself, and this is something what is indexed. Contains or starts with or ends with is looking for a substring within the pattern itself, right? So this is why it's less performant than the other one. And then regex is basically the slowest one that you can use. Clear?
Clear.
Alrighty. And as I mentioned on the first slide, when we did talk about does the order matter, it matters. As you can see here, we have device process events as a table. We are talking about time generated primarily, where we want to focus on narrowing our results at the very beginning. So be more specific at the first stage of your queries than later on. So more data you pull, the slower your queries are, and so on and so forth. Clear? Excellent. I will talk about ingestion lag in separate slide. It is mentioned here as a point, but we will get to it in a few seconds. So I'm just going to go a little bit through theory, through some other things here and basics, then we'll dive into queries and real things. Again, we did talk about union and join. What's the difference? So again, you see, for example, sign-in logs. We are taking anything that has happened in the last 1 hour, where the result type is not 0, which means the sign-in is not successful. We are joining with the device process event, and we are merging them where the IP address might be the device name or the device IP, right, as an example. Or when we do union, we are taking 2 tables, and then basically this will give us the result of both tables itself. Make sense?
Just a quick question.
Sure.
Why do we always check for time frames?
Because it will narrow down the amount of data you're getting. So it makes a difference because if your query and your query by default, for example, will fetch 24 hours, it makes a lot of difference if you're hunting on a table that has 20 terabytes of data daily ingestion. So instead of your compute processing all the 20 terabytes, it's gonna access only 1 hour. So it's gonna only get one subset of that information. Sure.
Charge like per query or not to?
No. So the question is, does Sentinel, does Sentinel charge you? So there are two tiers as we talked last time. There is the data lake tier or the lake tier and the analytical tier. Analytical tier does not charge you on querying, which means that anything that is stored in the active or hot tier of your configuration of the analytical tier, it doesn't come at any charge, which means that you can just query, right? But if you go to the data lake tier, you will be paying for the data retrieval, data processing, data storing, so on and so forth.
That's right.
So again, it matters even in a log analytics tier, like in the hot tier. It matters because, for example, if you are doing something in the hunting query that is compute intensive, it's going to consume CPU cycles, memory, disk I/O, and so on, which other functions are sharing within your SIM as well, right? So, for example, the data ingestion shares the same resources as your querying platform, right? So you might, with an ineffective query, you can affect other processes in the platform itself. So this is why it's important to kind of understand how to query efficiently. We're not saying, no, you cannot query our system, right? Or your data, it's yours to query. We're just trying to say you need to learn how to ask the right question or how to ask the question in the right way. Just a new line. So without a pipe, basically it's not a new line. It just considers it as a continuation of the statement.
Does it mean that it's after first one is completed, then?
Correct. So we have the table, then we have the pipe, which means this is the first stage of the query. Then this is the second stage. Then this join is the third stage, but then under the join you have this one, which is another set of data, which is another query that executes inside. But you see that join has this pipe here, but here it doesn't, which means that this is just a continuation for you. Yeah, because sometimes you might have a very lengthy query, right, in stage of a query. And you might not be able to see it. You might have to like scroll to the right to see your query. So you can actually just press enter to make sure that you have a new line so you can see what you're querying instead of scrolling and returning back, right? Does it make sense? All right. And one very important hint when you do hunt and you use join, the smaller table always has to be on the left. If you put the smaller table on the left, like the bigger table on the left, your query will be very inefficient. Clear? Sure.
You mentioned that in the two tiers.
Yeah, you mentioned in the two tiers, one of them you get charged if you query, and the other one you don't. What's the logic behind that? Is it because of the friction of computing and the data moving back and forth, or what's the logic behind that?
All right. So when you do collect security data, sometimes you need data where you can run analytical things, right? That's why we call it the analytical tier, which means in real time you can hunt, search, put your detection rules and everything else. But in certain scenarios, certain data doesn't have a high value for you, and it doesn't have to be in that particular analytical tier. You don't use it always. You access it not actively, irregularly, right? So only when you need an investigation or when you have a compliance case, right? As an example. So this is when you access data in a lake tier. So you have segregation because it is cheaper to store the data for a longer period of time. That's why that tier is cheaper. So if you need to do calculations in that tier, because we allow you to store that data on a cheaper price, then you pay for the compute at a later stage. Does it make sense? So analytical, you don't worry about compute. You pay a certain price for ingestion, and you can query as much as you want. Data lake or lake tier, since you're paying at a cheaper price just to store the logs, you will pay access to your logs separately. Processing, right? Make sense?
Yeah.
All right. So we do have a little bit on detection. We have two types of rules that are running on detection itself. So it's a scheduled rule, which we'll talk about the first rule itself, right? So this rule particularly, you need to define the query. So you'll set your query that you want to use as a detection, right? So for example, I want to look for events that are generated in 1 hour time frame. So this is the period we are looking back. Our items here are result type is 0, which means successful login. We want to look for the country. We want to summarize the countries, and we want to find the number of countries this user has been authenticated and where the count exceeds more than 2, right? So what's the idea here is it's impossible for a person to log in a short time frame from 2 countries unless he's using a VPN or that user is compromised. So this will become itself as an incident, right? Very basic query, right? But this is something what we want to talk about. So every query has a frequency, has a period, has a threshold, how we're going to group events, and suppression of events. So if I say, what is the threshold, right? What would you say? What does that mean? Even if you look at the description here. So in my case, what is the threshold here? No. 2 or more countries. So the threshold is actually here. How do we group data here based on the query itself? Summarize. So we are grouping basically by the user in 1 hour time frames, right? So that will be your grouping mechanism. Suppression is a parameter you will also set indirectly in the interface when we do talk about creating this particular rule. So, make sense?
Does like group by SQL works here or it doesn't?
Group by?
SQL language.
Correct. Exactly.
See group by, and I say like I specify like an attribute.
Correct. So when we specify summarize as an operation and we say by, that's the grouping mechanism in your query. But there is also a grouping mechanism in the rule itself, which we'll talk about very shortly. Okay, so scheduled rule has a frequency that you can set up by yourself. It has a time frame, it has a threshold, grouping, suppression. It has entity mappings and so on. We touched upon it last week as well a little bit. One thing to basically have in mind is that this type of a rule will always fire based on time generated, right? Unlike the second rule. The second type of rule, okay, we have a risky sign-in example here, right? So this is the description of the query I would like to show you, and I will actually open up Sentinel right now. And we will paste a particular rule here. Yeah, I will zoom in. I'm just trying to. All right. So this particular query I've written for one particular function and detection itself. It is used to detect when somebody steals a user's authentication token. So somebody tricked your user into providing a multi-factor authentication. They steal your token of that user and they start doing an activity, right? So basically, how we identify that, because there is a signal coming from Entra when a thing like this happens, and we are looking for risky logins. So what we're trying to say is we're going to look into sign-in logs, and we are looking for particularly events that have happened in the last 14 days. We are looking for risk level during signing is medium or high. So this is our filtering criteria in the query, right? And then we have some other parameters, right? But what is the purpose after that? We have something called office activity. So office activity is basically a table where all activity of a user in Exchange, Teams, or whatever Microsoft Office product line activity you do, this is where it's going to be tracked. Right? So what we are saying is we want to find users that have high risk level in sign-in. I am looking into that user after the sign-in, creating a new inbox rule, updates the inbox, or sets an inbox rule, right? It's a typical behavior when somebody compromises a mailbox, they will create certain rules for you not to see messages that are being sent or received. And what we are doing here, basically, we will match later on these risky logins by IP address and by username, right, at a specific stage. So the idea is I want to identify a risky sign-in user and a risky activity that's associated with a business email compromise, right? So when I run this query, ideally, like in my scenario, I don't have it, but it will generate a particular result. Hopefully, I don't have it in my tenant. I don't. That's good. But ideally, this will give you a result that a user has signed in, somebody has compromised his credentials or had a risky sign-in, and has executed specific activity in the mailbox itself. And one particular filter that I'm also applying here, I'm looking for specific subject lines in the message itself. I'm looking for invoice, payment, wire, bank, HR, payroll, typical things that are associated with a business email compromise or when somebody is doing a fraud from your account.
So Peter, I'm just trying to imagine like how security analysts work. So is it like you think of a phenomenon and then you write the KQL query for it and then you try to see the response from it? Isn't there like something like, let's say if you don't know how to write KQL, there's something in the system where you can just like, oh, I want this key log and then you just get it?
So ideally, like you have a lot of these detections coming in, right? So you receive all of these signals. But sometimes analysts do miss a lot of activity because this risky sign-in has arrived 14 days ago, and then you mark it as a false positive, believing, for example, the user just connected on a VPN, right? And that's why he appears on 2 locations. And is coming from a risky IP, right? But also a malicious actor can be behind that VPN IP, and they might be dormant for a period of time. So therefore, this mailbox activity will not be caught in that particular time frame.
The KQL is essentially their tool to sift through these thousands of telemetry data.
Correct.
And the reason we use KQL or QL is because KQL is more optimized for the engine in which these logs reside in.
So SQL is a query language for a SQL server. KQL is the Kusto language for basically it's a query language, but it's dedicated for log analytics, it's dedicated for ADX and other components. It's just part of the Azure ecosystem, right? So it's not more performant, it's just what the engine translates your question into and sends it to the database to return you the results, right? That's the whole difference. And additionally, there is one thing here, like what I'm doing. This repository contains all M365 server IPs. And one particular reason why we are using them here is to exclude legitimate activity from the backend system that you might be executing as well, right? So sometimes you might do an activity and that activity can come from a different IP that belongs to Microsoft, right? So we are excluding activity that is done from Microsoft trusted IPs from the M365 ecosystem itself, right? So this eliminates a lot of false positives that can happen during the search.
As long as it's accessible by Sentinel, you can rectify.
Correct. You can use externally, like you can use a CSV file, you can use a text file, you can create your own table here, you can create your own watch list. It's also covered in the examples later on. So ideally, what we have done here is we wrote a query, basically. That's the explanation here. So basically what the query does, it will find any inbox rules that were created by a non-Microsoft IP that are not coming from the IP address of the client's original sign-in activity. Make sense? Excellent. So why is this rule built? As I said, after a token theft, attackers can plant inbox rules to hide replies from finance, IT, or the victim. So we are pairing the rule creation with the risky sign-in, and then we basically do this exception for IP addresses from the sign-in IP and the trusted IPs. You don't. You have a continuous improvement process.
Okay, so how does that happen? Like if someone wants to tamper a file but doesn't want the organization to know, if I want to feed the SIM that at this specific time, there was the SIM was watching but nothing happened. I don't want to shut it off
So
completely.
the question is, how do you monitor file modification operations, right? From a SIM point of view.
Is there a file on the server that's sending the information?
Okay. So that is the job of a different component, by the way, right? So that component is called Microsoft Defender for Endpoint. And that is a separate product that feeds data to the SIM as well, right? So that particular table, and I will show you one very interesting link that we will talk here, and that is Azure Monitor Log Reference table. And it's a page. So you will find every Azure table here that is ingested in Sentinel. And the table we are looking for, particularly what you mentioned, is something what we call device file events. So this table is part of Defender ecosystem, right? Correct. So what does this particular tool record is file creation, modification, and other file system events, which means that any process that's running on your machine accesses a file, modifies, deletes, or writes, you will actually see that particular telemetry.
Okay, so I have to set up this specific
You need to use that particular software, right?
on every server.
On any endpoint, yes.
Okay.
And then your telemetry will come in. So it's not the SIM's responsibility to have that data. That data is actually generated by a security tool on your servers. The SIM just collects that data and represents it to you.
It's not a detection tool, just taking from all the software tools you are using.
SIM is a detection It's used for detection and response, right? And it's also used for logging and many other things. Okay? Great. And second type of rules is NRT. So NRT is a type of rule that runs every 1 minute and looks for 1 minute of data from a particular table. These are something that is very important for your network and you need to be notified immediately, as an example, right? So high fidelity signals, it will always return a single event. That event will be an alert. Identify something that you need to flag immediately. And this works not on time generated, it works on ingestion time, right? So it's a little bit different mechanism for time and other things, right? It's a single source table, no unions, no joins. So this is something that's very critical for you, something that you can easily detect, and it's a very critical thing for your organization. So you have a lot of restrictions in this type of a rule, but this rule fires every 1 minute and looks for 1 minute of data that has been ingested into the platform.
What is the maximum time period of this particular?
1 minute.
That's it.
Yeah, it's a rule that runs every 1 minute and looks for 1 minute of ingested data.
So if the log ingestion delay is more than 2 minutes, then it will not.
No. So there is a mechanism for that. So it tracks execution time and it tracks failures. So it knows that last execution grabbed data from this time frame to this time frame. And if it fails once, it will increase by 1 minute. If it fails twice, it will increase by 2 minutes. But it will run.
If the log ingestion delay is more than 5 minutes, then it will go back and then look back at it.
Correct.
Like that? Not it.
Correct. It will do 5 minutes ingestion.
Okay.
So
what about that one? The previous one, that is
the previous one runs on time generated, which means that already is in the table and it's stored and everything else.
What's the maximum time period of the scheduling?
The maximum time frame for a schedule is up to your data that you're actually.
My log ingestion is more than 90, for example. It's common 120 days, right?
Correct.
Yeah. So what is the maximum time period I can use for the schedule rule?
You can use 120 days, but then depends on how efficient your query is.
If I'm using this a single table, then what is a failure?
What do you mean single table?
For example, if I'm using only one single table for collecting the schedule rule, creating the schedule rule.
Again, what do you mean single table?
I'm using only one table for collecting for 120 days for executing one, creating the one use case.
Okay.
Using the schedule rule. So
Okay.
what is the time frame? So
You
how
can
long
define the time frame. We will talk about that particularly. And I have one particular rule that can go up to 120 days.
That is for
360 days.
only for collecting the data, right? What about the use case creation?
You can create a use case. Like, so for example, a typical use case would, for somebody looking that many days behind, is to create or evaluate their statistical baseline that they're creating for particular behavior, right? Or you're looking for indicators of compromise. So for example, you receive indicators about this IP, and I actually have that particular use case built right now that I want to show you. So somebody gives you an IP and you want to search 120 days backwards.
Correct.
You can do that.
But searching is fine. What about the rule? Schedule rule, I mean to say.
Again, the rule can look as well.
But Microsoft suggested only maximum time period you can use for 14 days for schedule rule as per the Microsoft.
Correct, but you can extend it.
How efficient it is? That's our question.
Again, it boils down to your querying capabilities. It's not about the efficiency of getting the data. If you ask for you to retrieve your entire data set for 120 days and your data set is 10 terabytes daily, you're retrieving a lot of data. But if you are asking that question in a nicer way, you will say, I want to know what has happened in the last 120 days, but I only need these two fields. So instead of you fetching 10 terabytes of data daily for all the fields, you're only fetching two particular columns. That reduces the load, which means effectively you're querying more performantly. So a table will just, again, revert to the tables themselves, right? You have a table attributes and you have columns. So instead of fetching all the columns from the table that will be equal to that particular size of 10 terabytes of that table on a daily basis, you only need file origin IP as an example and folder path that you're searching. Then it reduces the size of the data set and it's not going to be that intensive on the CPU, disk, and memory. Make sense? All right. Okay, so let's go into creating these rules, right? Just for you to see it. So that would be part of, sorry. Let's expand everything, and that should stay in the analytics itself. So here we can actually create rules. You can create your scheduled rule, and you can create your NRT rule itself, right? So let's create one scheduled rule. You define your rule name. I will just call it DD01. You can type your severity, MITRE mapping, status. This is where you paste your query, and you can say run the query every, and you provide a integer here, hours, days, minutes, look up data for last 90 days, right? 90. Well, you can look only 14. You can say 14. So on and so forth, right? So you can define that particular, run the query every 1 hour, define it every 14, and you can start it automatically. So now we talked about thresholds. You can define here how big is your threshold itself, right? So if you get more than 5 results, then you can actually start alerting on this particular rule, right? And we talked about also grouping. If you see here, you have to group all events into a single alert, trigger an alert for every event. So if you have 10 events as a result of your query, you can group them into a single alert, which means you'll have only one, or it will break it for every finding that you have. You'll have one alert per record. And there is also suppression. So if I enable suppression, basically it will, yes, sir.
I can group by specific criteria, right? So let's say group by IPs or country or.
So it will group that particular finding that you have, like your query will, or your detection will give you a number of events. Those events are grouped into a single alert. That's it. There is no mechanism to split it into different events. So either you split it per record or you group them into one. Okay. So once that is done, you can then continue through defining your alert. Yes, sir.
For this suppression, we stop the query for 5 hours. Now, will it not, like, for example, we have identified one IP and it's malicious. We have taken the action. Now the query has stopped for 5 hours. But will it generate for any new IP?
Correct. For new.
And it will only suppress for the alert that has been previously generated.
Previously generated, correct. Sometimes you do have overlapping windows in your query, right?
Yep.
And primarily, you will create these overlapping windows due to the ingestion latency. So sometimes you might have a log source not send you the data in real time. So let's say, assume that your on-premises systems, the internet went down, somebody dig out the fiber optic cable in front of your building, right? Happened many times. So you don't have internet. Effectively, your logs will not come in. And let's say in 1 hour, Orido came, repaired everything, your events start coming back, right? So you always need to have some sort of a buffer or basically overlapping window. So that is only with scheduled rules. Now, NRT rules operate on ingestion time, which means that even though events have happened in the past and they were not sent due to connectivity issues or whatever, then you reestablish connectivity. NRT rules will still inspect that particular data because they operate on ingestion.
So is there a way that we throttle these alerts basis on any specific field? For example, there is a brute force or password spray activity.
Correct?
It happened for 5 different users from the same IP.
Correct.
Now, I have taken the action, but there is some logs and it will generate afterwards for other users. So in that case, can I throttle for that specific IP to not generate again once because it will flood different type of alerts?
There are some parameters, right? So when we talk about alert grouping here, right, you can group alerts into a single incident, basically, and you can select on what entity type. So also, there is some correlation in the back that can happen, right? And it's also related to these mappings that we will talk about. So what are the mappings related to, or the entities, right? So you might have similarity across 5 alerts, but they all originate from one IP, for example. So they can be grouped into a single incident based on specific criteria.
So we do not have any way to drop the alerts itself if we have we have detected any specific field. For example, my key field to detect in that rule was the IP.
Correct.
Or let's say a hash that we have already detected. Now there is no way to drop it for the next 1 hour or 2 hour. Like throttling, this happens in
You
other.
cannot drop an alert because it's generated, right? And then if a new criteria comes in, another user is being brute forced from the same IP, right? And you have an alert. There is a way that it will generate an alert, but that alert will be grouped into an incident. So you're resolving an incident versus a individual alert, right? That is one way to look at it. Another way to look at it is by leveraging automation and logic apps, which we will talk about in the next session. So logic apps are primarily like a playbook that can execute specific actions based on data, right? So if your incident or your alert has some similarity with another alert, you can actually use a playbook to group them together. You can automatically basically even lower the priority of that one, merge it to or associate it with another incident. And you can also put a comment and close it saying already an active alert for another user. So there are many different things you can do with automation here. All right. And you can see here, there is the instant correlation, what I was talking about. Anyways, so hopefully this makes sense. All right. Any questions?
Where do we define the query? Where do we define the query?
The query is defined here in the rule logic. I just did not paste the query. You can write the query here in this field. Okay. The same happens with a NRT rule. When we try to define it, it's rule logic, everything stays the same. But as you can see, there are no time frame configurations, look back windows, because this looks in ingestion time, last 1 minute. And here you have these entity mappings that you can configure based on your logic and the data you get from the alert itself.
Peter, if I got this right, you would first start by writing the KQL query, and then you would use the analytical rule to sort of automate it and run it on a specific schedule.
Correct. So you will use the query editor tool to test your query, your hypothesis, or whatever. Once you have it tested, you deploy it as a detection rule. Whether that detection rule is NRT or analytical, it depends on what you're doing with the data, right?
And what's the action of this analytical rule? Like it just, whenever, if it detects certain records, like what does it do? Like it sends me an email, it sends me a team, like what does it do?
It will generate an alert.
Okay. Like an email alert?
No, it will generate an alert in the portal itself, right? So once that is in the alert or incident field here, you will see different alerts, right? So in my, I don't think you will see anything. If I say last 6 months, you might see, right? So let's see that. Excellent. So I have a couple of detected rules here. So what has happened is in my portal, I have alerts and incidents, and I have those particular findings based on my queries here. So I have a jailbreak attempt on my AI model. I have privilege role assigned to a user and many other things. Or for example, new account has been created with privileged roles, right? So as an example, if I click on this particular alert, I can say the new user, sample user has been added to a privileged group, password administrator, action taken, none. I want to see the query results. And here it will tell me what has happened, right? So my detection logic was I want to know who is creating a new user and automatically assigning him privileged rights. So somebody assigned sample user with password administrator role, right? And what has happened, it took less than a second for somebody to activate the password admin role. So this for me is like a privilege escalation thing immediately, right? So as an example, I'm just starting to kind of monitor this type of activity, right? And for me, this is an alert to investigate something. Because I've never seen somebody get a role and automatically assign it to himself in a matter of seconds, right?
Like, how do you know what query to write? Is this where your skills as a security analyst and cybersecurity expert comes in?
Correct. So certain things you monitor from around detection rules, right? You look into real incidents and how incidents unfolded, right? So whether they've used phishing emails, whether they used specific items for initial access, what are their tactics after that, like modifying accounts and things like that. So based on that, you gain knowledge on what to build.
You can also use like Copilot.
Sorry?
You can use Copilot as well to help you out.
Copilot is amazing for this, actually. You can just feed it a bunch of threat intel articles and tell Copilot, you're a KQL expert, please provide me with a query for detecting this. It's not going to work immediately because first you need to go back to the page what I was referring to, right? And tell Copilot, this is the table where those logs are stored. So it knows on what field to look for what. So play around. It takes time a little bit, but it will definitely generate a query that is efficient after some time. So you need to understand how to query, how to ask Copilot to basically build you something you need. Yes. So the queries are actually built already, right? A lot of them. So when you take a look at the Content Hub itself, it comes with a lot of interesting content by default, right? So let's assume your organization uses let's take here. There is log4j vulnerability detection content pack. And based on that, you have different packages and it tells you what it is. So this is an analytical rule for detection, right? So the analytical rule here is user agent search for log4j exploitation attempt. And you can actually see the query here already. So it looks through your web server logs, your sign-in logs, your other activity, right? So technically speaking, a lot of content is built by the community and by the vendors. But if that content does not exist, you can actually build something of your own. Hopefully that makes sense. All right. Now off to a little bit more interesting topic. We were talking about indicators of compromise. So a lot of organizations do subscribe to threat intelligence feeds, and they do receive, in Qatar, you will receive notifications from the cybersecurity agency around malicious IPs, malicious files, viruses, behavior, so on and so forth. So, as I said, you can basically define your data, whether it is coming from an HTTP file, GitHub repository, or even threat intel feeds that can be integrated in Sentinel. And you can hunt across your environment, or not hunt, but search for these particular indicators yourself, right? And I'll give you one example. So here you can see that we are getting a file from somewhere called iocs.csv, and we are searching in file events where the file hash is or contains any of the malicious indicators we see, right? So let's have a look on how this looks in real life as well, and how we leverage the threat intel platform itself that can help you do this task more easily, right? So as you see here, we have a threat intelligence blade. So let's go into the intel management. And you can see basically we have indicators, patterns, identity, threat actors, relationships, so on and so forth. So here is where we create a object for threat intelligence, right? And that observable can be a domain name, IP address, file, user agent, so on and so forth, right? And you can see in this case, I've created two indicators. I have 1049, 21253, and 1234 as an example, right? So every time I add a new object, it can show up here, right? I'll just say I will add a new observable, IPv4 8888. I will call it Google DNS. Indicator what it is. You'll say it's benign, or you can mark it, right? And then you have different fields that you can actually input or specify for your particular indicator, right? And once you have these indicators, you can create automated rules to look for your indicators every day or every hour. So what happens from this point is that all new data that comes in will be searched for these indicators on a specified time frame, right? But if you want to search historically, so once you have new indicators, but you want to understand, have I seen this before somewhere else? I've prepared a sample query, right? So what does this query do? I will explain in a second. We are looking into the threat intel indicator table, where time generated is based on a look back behind. The indicator is active. We are looking for IPv4, and that the indicator is either modified or created in the last 24 hours. So I'm only looking for new indicators that I've created in the last 24 hours. And I can run this query. And this query will run across all of my data sets or whatever I specify in that particular query. So if I run it, sorry, I will have these empty spaces, sorry, yeah. I will find that, yes, I have a hit for one particular IOC in my network. So you remember I defined one IP address, 1049.212.53. So I found that in my environment today at 128, this particular IOC is discovered making in our network traffic, right? So our internal host was reaching out to this particular IP. Clear? All right. Any questions?
Yes. We added, you added one object. Yes. Add a whole file.
Correct.
Multiple IOCs together because
Correct.
once we receive it from here and from the NCSA, we have a bunch of IOCs.
Correct. You can import in different ways, right? So you can use the threat intel management. You can use a CSV file or a text file and upload it in your own web server or in a GitHub repo. You can actually use something what we call watch list as well. So here, a watch list can be used for indicator like that as well. Or you can define your most critical users in your network or your most critical assets. You can call your watch list as executives and you'll put their emails there, right? So you can easily reference something in your hunting queries. So you can use a text file, a CSV file on any web server and upload it. You can create a watch list and import a CSV there to run that particular hunt. You can use threat intel indicators within the platform to look for threat intel indicators. Correct.
We can use this in the queries as well.
Correct.
Yeah.
So watch list can be used in a query. I've shown you an example how you can use an external file, and we can use indicators of compromise as well from the threat intel management.
So Peter, basically, I can think of IOCs as like someone already, like a certain central institution already detected that these certain IPs or certain file hashes or certain domains are suspicious. They're like, it's like a wanted list, and I can just put them into my
Correct.
sort of monitoring solution so that if it's there in my system, I get alerts for it.
Correct. So the benefit of when you get these alerts, right? So if you, for example, use a watch list, right? What I want to highlight here, and I mentioned it at the very beginning. So if you use a watch list, it will not be highlighted unless you run a query that references that watch list. If you reference an external file, it's not going to be flagged for new activity unless you build that query. But if you use the threat intelligence content pack and the threat intelligence feeds and you keep them up to date, we will hunt continuously for these queries or indicators. We will search for these indicators continuously, right?
We cannot add those in the threat intelligence at once, like we have to do one by one.
You can do API calls. So you can upload a lot of indicators with APIs as well.
It's a separate topic to discuss.
Correct. But there are ways to bulk import data, right? All right. Clear? All right.
We have 15 minutes left.
Sure. We will, the other two topics I wanted to talk about are very short. So summary rules. So this is one amazing thing since I discovered it, to be honest. So what is the idea behind summary rule is to run a computational query and save the output into a table. And this will run on a scheduled interval. Why is this useful? Yes, sir.
Maybe when next time you want to refer to any of the data that's now that's in this table now, you don't have to compute it from the start. So it will reduce the friction of back and forth computing.
Excellent. So if you have large data sets and you're establishing a baseline and it's something custom you want to build, summary rule is your friend. And I'll give you an example. I use this a lot. So I've built a tool that simulates DNS traffic and malicious traffic by itself, right? And you can see these summary rules running in the background here. So the primary idea is you run a query on a scheduled interval, it pre-computes data, like it calculates everything for you, summarizes based on your query, and it's going to save it in the table. And I have different DNS and metrics that I'm gathering here. So just to speed it up, when you do hunt, for example, DNS-based threats in your network and malicious DNS traffic, there are a lot of things you're looking after, right? But I want to basically just dig deep into one particular item. So I built a rule that looks for all of my DNS queries, and it's going to give me the domains that are queried the most, but have a unique query name, which is a sign of beaconing, which is a sign of data exfiltration over DNS. And what will this give me, right? As you can see here, we have results. It's going to give me the client IP that requested. And I have the top domain, which is basically here, msonline.biz or example lab broadcom, like misspelled items, or smantec, msonline.biz, and so on. I see that this machine queried this domain 1,226 times with 370 unique names. This is irregular, right? So, and I don't have to run this analysis every single time. So I have a query that analyzes this for me, and I only have to look up this table, set up thresholds based on the environment itself, and it's going to flag to me every time I see an irregular query. So detecting DNS-based threats in your environment using statistical analysis. You have just one summary rule that aggregates data, and you do the partitioning yourself. It saves a lot of time in hunting. It saves a lot of time in detection as well. Questions? Nothing? Clear? All right. So I did prepare like 3 summary rules, but we are running a little bit out of time. No worries.
Busy,
I have a question, but I don't know how to ask it.
Sure.
I still don't know how to ask it, so hopefully you can understand it. So
We are working here on Windows Defender, right?
Yeah.
So we're using the KQL to set the rules. And when, right?
KQL is saying the rules, yes. It's not only for Defender, it's for Sentinel as well, right?
Okay.
Sentinel is the same. Defender is the protecting ecosystem.
Sentinel is the same too. Okay, so we set the rules on Defender, and then, okay, why we use KQL on the SIM to just search for the IOC?
All right. So ideally, right, the Defender ecosystem is, or the product line, protects your assets, right? So it should protect you from this malicious activity, but attackers are very clever on bypassing techniques, right? So ideally, you have your protecting system or protection system, prevention system, right? That logs everything what is happening. So you will have detections that are missed sometimes. You will have visibility gaps or protection gaps. Maybe somebody disabled the block mode of your tool, right? So for example, your admins can change and so on and so forth, can change settings and create exclusions that will not basically fire a prevention rule that will block that particular traffic or particular process. So therefore, you're using a query language basically to identify things that are missed by your prevention controls.
this is like prevention system, and the other
So Defender ecosystem or product line is the prevention thing that we are talking about. SIMs, so firewalls are also preventative control. Your web application firewalls, all of that is a preventative control. But all of these logs are indicators, and you search for something that your systems did not prevent. That's the whole purpose of it.
Okay, but like, isn't the SIM using the same rules?
What do you mean? No.
Like, I mean, we're setting the rules here.
Correct.
And it goes to the SIM. So I think that
everything you're running, so the rule is built on the SIM. So again, these rules are running on your SIM platform. They're not running on the prevention system. They're running on the detection system.
But the prevention system is sending to the detection system.
Correct.
So it has the same rules.
It can leverage the same rules, yes, but the prevention system does not take a rule from here and convert it to a prevention mechanism, right?
But thinking this way doesn't mean that the SIM has the same outcome.
No, it doesn't. So the preventative control has its own configuration. It doesn't have to be a Microsoft platform. We are talking about, previously we were talking about firewall logs. So you might configure your firewall to allow you specific traffic, right?
Yes.
Excellent. And now a threat actor bought a VPS somewhere, IP address 8833. It's not blocked in your firewall. How do you detect it? Based on the traffic logs.
Yeah, this is when we talk about the firewalls
Correct.
and the infrastructure. But when we're talking about the platform, like as I remember, you said that Microsoft Defender is sending everything to the SIM.
Correct. It's sending, but again, preventative controls are one thing, detective investigation is something else. So you need to decouple it.
Oh, okay. So it might detect it, but not prevent it.
Correct.
Okay.
As I said, we are hunting for activity that is not detected by our tooling or prevented by our tooling. So that's the whole purpose of it. Sure. Please answer.
SIM is like mind that thinks without needing you, because if you want to like look for the logs for each preventive tool, you will take too much time to search for logs. So if you want to see logs for firewalls and Microsoft Defender, then like EDR, you will take too much time, and then the threat will be like vanished, and you cannot regain back again. But the SIM tool is like gathering all the logs for all this system and building like a total incident that you can cover, and you can build a search rule based on that after that. So it's like it's decreasing the mean time to response and the mean time to detect with the SIM tool. So you can focus on how to search for a threat or how you can discover it if it's not detected by a preventive tool. That's what I understand, if I'm correct.
More or less, yeah. So ideally, just to summarize, prevention tools are there to prevent an incident from happening. You can configure it. There can be misconfigurations, that there can be vulnerabilities of these tools. Ultimately, you will refer to the logging system to identify something that was missed by your preventative controls. Simple as that. This is what we're talking about primarily. And I've prepared 3 different summary rules, right? So we've looked into one already, but we can go through all the others. But they're always focusing on the same thing. I'm focusing on DNS exfiltration, malicious DNS domains, have we seen something, so on and so forth. So I will skip the remaining 2 summary rules for DNS. We can revert back to them as well, so no worries. And I want to talk about notebooks. So who here is focusing on data science? Alrighty, what are Jupyter notebooks?
You mean Jupyter notebook?
Jupyter, yeah. I call them Jupyter, but it's okay.
I'm sure there's some people here in the audience who have worked with Jupyter notebooks before, but essentially it is a sort of interface where you could run Python code. It has like a kernel,
and you could run different Python libraries, could run visualizations, and do some data exploration, experimentation, and so on.
Exactly. In Sentinel ecosystem, right, or in Defender ecosystem, when do we fall back to notebooks and Python? When what we want to inspect or detect cannot be completed with a simple KQL query, because there are a lot of functions within KQL that are not implemented, right? Any query language, they have their own restrictions, and you have a lot of mathematical functions available in Python, a lot of other things, right? And also you can connect to many other libraries. So you can connect to any external RESTful API, you can connect anywhere, you have a lot of freedom, right? So this is where we fall back to notebooks. Hopefully this is clear. Now, do you know what is entropy? The term entropy. In physics, in mathematics, in anything. What does entropy stand for? Randomness, right? Excellent. So the example I will show you now is again related to DNS using Jupyter notebooks. And it's running in Azure right now. And it's running natively within Sentinel itself, right? You have the notebook section here. So here we will do entropy analysis on DNS traffic. Why does this matter for us? Why does entropy analysis matter in DNS analysis? And you can do it also on web traffic as well, but here.
Because if we see any pattern of consistency in DNS, this can be an indication for a C2 or botnet.
Exactly. So we are looking for C2, which is command and control traffic. We are looking into data exfiltration or any irregularities in DNS. So I've prepared a very interesting data set as we looked before for DNS itself. But here you can see we are installing additional libraries for Python, including matplotlib, pandas, to do some crunching down in some math, right? So I'll just run the full notebook. But in a nutshell, we are importing these particular libraries. We are connecting to our Sentinel instance. We are authenticating to Sentinel that we specified up with a managed identity. And then we will run a couple of queries, right? So as you can see, we are connected to the Sentinel environment. We connected to the log analytics. Here is a sample query. So we were able to get the data from Sentinel as a test. And we will carry on with our analysis. So here it will take a little bit of time because we are fetching a lot of data, reparsing it, restructuring it, and later we are doing some very interesting analysis. So what we are doing is basically we're looking into all the DNS queries that have happened. We're looking into the domain we queried, and we are looking into the data that was queried for that particular domain. So let's have a look on. This is still queued. 50 seconds. Okay, it takes a little bit to run. Okay, I got a response. It's not displaying all the results, but we fetched 400,000 rows, which is good. Now here, we have a little bit of a chart, I believe, which talks about the distribution. Yeah, the distribution label. And here, we do see two domains that stand out in our analysis. So in our hunting and our hypothesis paid off because we found two domains that have large entropy of their DNS queries that were sent from our network. So now when we scroll down, we can actually see which client IP created how many queries, how many distinct domains it queried. And here we can actually see as an example, which are these clients that fall into that category. And here we can actually see that particular randomness, right? So we see a lot of randomness in our DNS queries towards evil.test as an example, which basically stands out for DNS exfiltration. So somebody stealing data over DNS from your network. As an example, you can base64 encode a simple Word document and send it as a query in multiple sections to a DNS server in form of an DNS query. Quite funny.
Yeah.
Yes.
So you cannot achieve these kind of results or do this kind of investigation through KQL.
Sometimes you can, sometimes you cannot. I'm just showing an example. Yeah, but usually you fall back to notebooks when something cannot be achieved in KQL.
Okay, and what's like, do we have the concept of workbooks in these tools? Like, you know, the workbook
Correct.
in Azure. So what's the difference in workbooks and like notebooks, I would say? Like,
So the question is, just to emphasize it and repeat it, is what's the importance and the use of workbooks that are known in Azure and in log analytics, right? We use them for visualization and drill downs primarily, right? Which means that we can take any query and provide you some visual graphs or dive deep into it, right? And sometimes they can be used for hunting as well, right? It will provide you like failed logons, unusual sign-ins, and things like that. This can be displayed. There is content already. But sometimes this is very limiting, right? Because if it's going to return to you large number of users, right, or a large number of entities, it's impossible to graph sometimes like 20, 30,000 points, right? You will not be able to see it through a graph itself. So sometimes you need to basically use external libraries and external data that might not be available in KQL to kind of remove the obvious, right, with some mathematical functions. Sure. Questions? Sure.
Do we have cost for this, like compilation cost or the resources we are using? And like achieving this from by seeing all the code, it would take a lot of time. Like if I take a hypothesis, I will have to go in step by step. Maybe I'll find something, maybe I'll go back to start. So I will run a lot of queries. How to, what is the best way to hunt to save the resources as well? Because it will impact the other resources, as you said earlier. And what is the cost if there is any?
So I did cover the cost from the analytical and lake tier, right? So this is one thing that has to be clear. Now, the Jupyter notebooks, basically you need to run your compute. So this runs on a virtual machine in Azure. So you are paying for the CPU cycles and everything that's running for that particular machine. You're not paying for the data between your VM and what you're querying from an analytical tier. So that will not be billed. The thing that's going to be billed are the CPU cycles, right? And that particular resource. Yes, Fatima.
Locally, like my local Python environment, I just connect to the log analytics workspace and.
So as we are using a managed identity, and that's our like recommended way of integrating with Sentinel, you need to use Arc, right? Azure Arc to basically have that managed identity. You can use a Entra app, which relies on OAuth 2 authentication, which means secrets and whatever not. But that is something that somebody can steal your secret from your machine, right, or from your code. So this is why primarily we rely on a managed identity. But you can.
User identity?
You can as well, but you need to write it in the code. So for example, here, I am specifying that particular authentication to be from the managed identity that's associated with the machine learning space, right? So this is where I'm actually setting up my credentials. So you, instead of using these credentials, you can maybe use your AZ login and then use your token from there, right? But yeah, you can use it, but like ideally, if you're wanting to have something repeatable, not just for yourself, but for your entire team, you can leverage the machine learning workspace in Azure itself, right? Additionally, just to kind of highlight, you can connect your data, like so as you see here, the connections. I've actually connected it to my GitHub repository, right? Which means that all of my notebooks, playbooks, whatever I'm building for this particular detection will be stored on my repository that's shared between everybody in that particular tenant, right? Now, you did ask me around the complexity of writing these things. 90% of the time, now for me, I know how to explain it from a point of view as a hunter and as an engineer, how an LLM should query it. How an LLM should basically spit out a query that's workable for you. So this example that you see here is built by a copilot. It just took me 5 prompts to just refine what I needed to get out of it. Yes.
Say this to give that all the security logs to the copilot to get the securities.
You're not giving security logs to the copilot. So I'm basically prompting a copilot stating, I want to write a Jupyter notebook for Sentinel using the Sentinel library. I am hunting for this. This is the data set. These are the fields in that particular data set. I am interested in entropy analysis for DNS. And it will just go nuts on it.
Her question, would Microsoft Security Copilot, like the product itself,
Correct.
come into what she's mentioning, like the built-in one within the port, like you're able to chat with your logs?
Correct.
In a secure manner? Are we going to see demos of that maybe next time?
That's scheduled for the next session, and I will be presenting together with my colleague Vikram.
We love Vikram.
And we will be talking about Security Copilot in DLP incidents, primarily data protection. And we will be talking from a security analysis point of view where you want the Copilot to behave as a security analyst. So it's going to be a very interesting demo as well. Questions?
Let's ask more questions because Peter has a name again.
You please can you give us like an attack scenario, like how the attack is being prevented or correlated to the SIM, like from the beginning to the end, like very quick.
All right. So as I was talking initially, right? So we did talk about a particular query that detects the first query I actually shown you, right? So that was this one. Particularly after a token theft, attackers commonly create inbox rules and whatever, right? So the scenario will go as follows. Somebody has bought credentials from your user from the dark web, right? Which means entity A on the internet is selling data on the dark web for a company that you work in. As a security analyst, you have the rule I specified earlier, right? And you will see a risky sign-in by your user from a VPN gateway or a public VPN service or a Tor node. And you've seen this user do this before as well. So you safely ignore that particular alert. You don't do anything about it. They are dormant in your network for a week or two. They just tested the account. 1 week later or 10 days later, they start modifying inbox rules. They start sending emails. You don't know anything until this point. It comes to you 2 days later, somebody tells you, we lost more than 10 million riyals in the company with wire transfer fraud. What do you do?
Go to the as a security analysis, as I know, we just go directly to the SIM and start search for the IOC depending on the scenario.
IOCs. What will you search for? There are no IOCs.
You said some data had been
You ignored it. You said it's a false positive.
I go to the SIM.
Okay.
Because it has all the logs, and then I search for this the specific data being exfiltrated.
There is no exfiltration. Talking wire fraud. Nobody exfiltrated data.
They modified data.
They modified your on the exchange. They modified that your finance person will not see an email from somebody, and there somebody basically impersonated that user later on, saying these are our new bank account details. You sent the wire transfer, but 2 days later your supplier calls you and tells you you did not pay us. And then you realize that you've authorized the payment for somebody else from your finance department. What do you do?
Okay, what I do, I can fix the problem, but I cannot.
How are you going to investigate it? This is what I'm trying to tell you now. So you are in that scenario.
Okay. I just, the first thing comes to mind is the SIM. We go and search, for all the transactions happened at that specific time, maybe, and the files that been modified.
There are no modified files. Again, we are talking about a mailbox. We're talking your email, your mailbox itself, right? So again, the entire crime has happened by somebody stealing your details of the finance person, getting into his mailbox,
okay,
and creating a rule that basically will ignore original suppliers send their emails. They will be put in a junk mailbox. Somebody else presents themselves as that same supplier, saying these are our new banking details. Your finance team will update the banking details into your ERP payment system and initiates a transaction to pay the bill.
So what can I do? I can fix the rules, but I cannot fix.
How are you gonna know? This is what I'm trying to tell you.
I can know because isn't the SIM telling us what's been modified in the rules?
But you need to start a hypothesis, so you need to start from somewhere. You cannot say I'm going to look for indicators when you don't have an indicator.
Won't the user who's in charge of all the finance and payment gets indicator?
Exactly, but how do you start? How do you get to that point?
I mean, after the incident has been reported, we know who are the main POCs for that email fraud.
Yes, I know what's
You
being.
start with looking into the user's mailbox. You will say, what did you receive from the supplier? So then you will identify that. Then you'll start searching for the original emails of that particular supplier. And then you will identify that somebody created a mailbox rule to move the data into junk. So that would be your investigation pattern, right?
Okay, all right.
And from that point, you will identify how did this happen, and then you will find in your SIM at this point that somebody created this rule, and it will point to the IP address that you safely said, hey, this user is known to use this VPN, and you've ignored it. You actually received the original signal that the user is compromised, but you safely ignored it because this user in its history exhibited risky behavior.
Okay, so I have to go to the user's account first.
Correct. You need to investigate from the user's point of view always.
Okay, so if there are too many users that's been compromised, I have to go.
Then you hunt across all of your users. You look for the same indicators of behavior in this case. So has this been triggered on all of my users before?
Okay. So the SIM is not the first option. It's
It
maybe
is the first option, but you need to identify where you're going to start investigating. So if we've identified that finance is the only one who authorizes this, so you will ask your finance what has changed. Because it's not only that you will identify this on somehow. How are you going to identify?
How it compromised?
Exactly, but how are you going to identify when you have a lot of signals in your environment, a lot of data? You need to start from something. So ideally, you would start who has access to change the financial records, right?
We have strong password mechanism, then multi-factor authentication is there in place. But still, if this certain scenario happens, then
multi-factor authentication can be bypassed.
Way maybe I'm thinking that maybe he used his personal device to log in, and then his personal device was compromised.
Falls under risky behavior, exactly, which you safely ignored because the user previously experienced that.
And maybe attacker used the token, authenticated token, to compromise his account.
Correct. So typical, what happens in this type of scenarios is the authentication token theft.
So corrective action, maybe you can expand the token using conditional access policies.
There are ways of preventing that, but it is still a very common thing that's happening. And a lot of security operations center people and security analysts are overlooking this particular matter because your users, they can use their email on their personal phone, and that user can use a VPN. So quite frequently, you see this user logging in from Qatar, from your enterprise network, but occasionally you see him browsing his mailbox or being authenticated from a VPN. So what do you do when when an actual event comes in? Again, you're flagging the same risky behavior from the user that continuously does that. That becomes a little bit of a analyst's nightmare because you will either prevent them and tell them adhere to the policy, but a lot of organizations don't do that.
This matters here because if you create a policy that no one should access through the VPN,
then and you enforce it, then good for you, then you can do it. But a lot of organizations, unfortunately, still to this day don't do that.
If they understand then we can force it.
Correct.
If the user is like a VIP, they can bypass the policy. They usually do. And in this case, like this mailbox rule modification, if a user is compromised, the second thing for the exchange for the Outlook is this thing, because I can vouch for it. I have observed this in my career a few years back. Similar kind of scenario, finance head has sent an email to clear some invoices. And fortunately, we had the rule implemented, and the guy who received it knew that the head of finance was on leave. So we got safe, but very important rule.
Very important thing, exactly. And it's a quite common thing in a team in this region, to be honest.
We have seen that the authentication, even the MFAs get bypassed in the history. So we had to have the other steps covered for the elections.
I'll give you another scenario similar to this. Like a lot of executives give permissions to their mailboxes to the assistants and the secretaries to schedule calendar and sometimes reply to emails. So I don't have to target your CEO. You get my point?
Yeah.
I can just target the secretary who is not a VIP, that doesn't have all of these controls, but she has permissions of the CEO's mailbox and has happened so many times before. Right. Anything else?
Can you give one more scenario? No, it's very interesting. Like maybe something you come across before. Like this wire transfer thing that you came across it before?
Yeah, of course. More than thousands of times, actually. In like 10 years of being in incident response, I've come across so many times as an investigator.
What about the creation of application using SharePoint or using the SharePoint to share the legitimate links after compromising the user, which redirects to fake Microsoft pages?
So a lot of things can help you in this type of scenarios, right? So ideally, when you look through different data sets in your environment, right? So if an email, I'm just going to brainstorm a little bit here, right? So you have a table that, let's assume you're using Microsoft 365. You have different tables here, and some of them are email attachment info, email events, email URL info. So what's the purpose of the email URL info table? So basically, any link that is contained in the URL will be displayed here, right?
Does it include redirection?
You'll have the network message ID, you'll have the URL, URL domain, URL type. So for example, if an email is shared from SharePoint, you will see that data here because SharePoint will leverage your tenants exchange, right? Or your app will leverage if you configured your app. So you will leverage your particular email. So you'll be able to identify when an email left your system, and you can actually find your domains if you're using E5 and you're logging the data. So it's very easy to identify different things if you know where to look. Trust me, this Azure Monitor reference table is a lifesaver.
So let's do what we usually do at the end of our sessions, which we're going to ask some questions to the audience, and then they're going to get some goodies.
Alrighty.
Questions. Don't shout out the answer, please. You'll be disqualified. And then you're going to get some, let's see what we have this time. I think we have some water bottles.
Yay. Water bottles. Hopefully this was fun.
Yes.
Interesting.
Just once.
All right.
One question I missed out.
Sure.
So please pass them.
So you use that summarization, the makes it, right?
Sorry? Make set, make
Summarization,
list
yeah.
sometimes. Yes, correct.
Why we need to use the directly you can use like summarization?
Because
Then-
if I use a let statement, which basically kind of creates a table, you
Mhm.
cannot reference a table as a variable for something you're filtering. You can use it for joining, but if I need to use a list to basically search for an IOC, so for example, if my table has 2,000 entries, 2,000 rows, right?
Yes.
I cannot use rows in a has statement.
Has any you can use, right?
Doesn't matter. It has any, has, or whatever. No, you cannot use it for one particular reason because that is considered a table.
Okay.
So you need to pass a list.
Complete list.
So that's why we go to make list or make set. Hopefully that makes sense.
Yeah. So what is the difference between makes it and materialize?
Oh.
Is it a long thing?
No, it's been a while, like, because I haven't used materialize in a long time, but use make set.
Makes it. So better than
Make set or make list, yeah. Materialize has some restrictions in, I forgot some. I'll get back to you on that one in the next session, definitely.
Okay.
I'll make note of the question. I'll revert back to you.
Okay.
What's your name?
Kareem.
Kareem, yeah, no worries. If you're coming next week, I'll definitely answer.
No, if you approve, then I will come.
No, of course I will approve. I don't know everything, honestly. Like, I believe this would be answered by an ADX team, why materialize is better than, and why it's
Thing on the
not
data
yet.
engine level.